Hi everybody, in this video we're going to talk about the third algebraic technique for evaluating limits. Sometimes all it takes is just manipulating a few fractions. So as always, we start by attempting direct substitution. If you try to substitute 0 in for x, let's figure out what we get. Again, I'll always encourage you to pause the video and try yourself. So if you do that, you get that magical 0 over 0, which is telling us that there's some other version, something that can be canceled. So where do we start? We have a fraction minus a whole number on the top. Let's get rid of this here whole number and rewrite it as a fraction with a common denominator. So let's do x plus 2 over x plus 2. That looks like 1 to me, something divided by itself. So the key to subtracting fractions, as always, is common denominators. Now that we have a common denominator within the numerator, we can subtract the numerators. 2 minus 2 is 0. So all we have is x in the numerator. Let me write that out a little bit better. In the numerator, we have 2 minus x plus 2. So we have 2 minus x plus 2 over x plus 2 over x. Common tendency is to forget about this x in the denominator, so be careful to bring that with you on all steps. So now we're going to distribute this negative sign. 2 minus 2 is gone. So all we have left is, on the top, we have negative x over x plus 2 over x over 1. Just throwing that out there. Complex fraction. Hopefully you remember that the x in these two positions do divide each other out. If you don't, remember that this is the same as saying negative x over x plus 2 divided by x over 1, which is simply negative x over x plus 2 times 1 over x, and now we can see that those x's take care of each other, they divide each other out. So now we get negative 1 over x plus 2, and hopefully that will allow us to evaluate the limit as x approaches 0 of this function. It absolutely does. Stick a 0 in right there, and you simply get negative 1/2. Once again, it's definitely worth checking out the graph of this thing to make sure that the equivalent original function and the new function really do look the same. So let's do that. This red one is the original function where we started. Negative 1 over x plus 2 is where we ended. Again, confirming that the original function was undefined. Adding the blue one. Actually, it's not blue anymore. Sorry about that. Adding the green one on top of the red gives us an equivalent function that is plugging the hole when x is equal to 0 to get negative 0.5. As always, let's look at another one. To try your hand at this. So take a look at this one. Again, the key is common denominators of the numerator in order to subtract this thing. So again, I encourage you to pause the video and see what you can come up with on your own and then compare it to my work. I'll be with you in 1 minute. Here's what I came up with. First things first, when you try direct substitution up here, when you try direct substitution, that'll be the next video. When you try direct substitution, you do get 0 over 0. It means it's removable discontinuity. This one was a little trickier because you had to change both fractions. So what you want to consider is the black ink is the original function. Take the 4, put it over itself on this here. Take the 4 minus x, put it over itself here. We did a lot of this in the trigonometric analytic trig unit, kind of manipulating fractions and all over the place here. Once you do all this work, again, don't forget to bring the x along for the ride the whole way here. Don't forget that this is subtracting this whole quantity, so stick this thing in parentheses. 4 minus 4, negative x, gets you just x on the top. which, just like the previous example, the x and x are going to divide out, as you can see over here. The x divides out, so your new function is 1 over 16 minus 4x. Of course, you just distribute there. And once you get to this green equivalent function, simply take 0, put it in for x, and off to the races. 1/16 is your limit as x approaches 0.